Hello everyone. Today we are going to discuss the fourth problem of Leetcode Weekly Contest 377, which is minimum cost to convert string to. So what is the problem? We are given two strings, source and target. So we have to change the source string to the target string, and we can do this following operations. We can change. We are also given two arrays, original and changed, which is string arrays. So we can convert original I to changed I with an cost of cost I. Cost is also an integer array. Now we have to change the source string to the target string by these following operations. So we can pick substrings and change it into the if the substring is equals to some original I, and we can change it to changed I, right? And for any two operations, the the chosen substrings should be same, and it should be disjoint. It should be same or it should be disjoint. Like, let me explain that. Let's say for a operation we have chosen is 1 to 4. Now for the next operation we can choose is 1 to 4, right? We can choose is 1 to 4. This is possible. We can choose is 5 to 7. This is also possible. But we can't choose some overlapping substrings. Like we can't choose is 2 3. This is not possible. We can't choose is 2 to 4 or is of 2 to 5. That is not possible, right? So only strings which are equal to some previous operations are allowed, or only strings that is disjoint from the previous operations are allowed, right? I hope you got it. Now let's jump into some observations. So the first observation we always make with the constants. The constant on source length and target length is 1000, and the constant on the original length and cost length is 100. So the problem could be solvable in, let's consider the source length as n. Let's consider the source length as n, and original length as n. So the problem should be solvable in order of n square, or order of nm, or order of anything like n square or n square log n, right? That, but the time complexity of this problem is so strict that order of n square with hash map is not allowed. So I am not able to solve the problem in the contest. I was getting TLE with order of n square solution with hash map, right? So let me explain my idea first, then I will try to explain what could be the further optimizations I have did after the contest to solve the problem. So what is one possible solution, right? So the first thing you have to observe is that that is with the third problem, minimum cost to converting one. That is also that we have to do we can change. Let's say we have some string original I, we can change it to chi, right? Now after changing it to chi, we can further do some transformation and convert it into chj. Okay, that is possible, right? Let's say we are given some string ab, we can convert it to bc. Now we are given some string bc, we can convert it to cd, and we have some string cd, and we can convert it to da. So that means that we can convert it ab to bc, then bc to cd, then cd to da by these costs. Like, we will do first operation, second operation, and third operation consecutively to change ab to da. So that is possible. So so we can consider ages between AB to BC, right? So we can consider ages between AB to BC. Now there will be age between BC to CD, and there could be age between CD to DA. There will be weighted ages, right? So there could be some weight W1, W2, and W3. So there could be also an age between AB to DA with weight W4. So we have to for every pair of vertices in the graph we are constructing from the edges, we have to find what is the minimum possible path between any two nodes. So this is solvable using Floyd-Warshall algorithm. Floyd-Warshall, you can search it in GFG or any CP algorithm. So Floyd-Warshall. So the time complexity of Floyd-Warshall algorithm will be order of n cube. So order of n cube. Now order of n cube means what is the length of the changed or original array. The length of the changed or original array is m. So the time complexity for this algorithm will be order of m cube, right? Order of m cube is allowed because m is 100 and n is 1000. So this is allowed. So this is the first operation we will do. So for this we can't really use a map, right? Because the length of any substring, any string present in order original or changed the length would be 1000. So we can't really store them in a map, right? So because every operation, inserting it into the map or getting it into the map, we will require one hash, right? So for further operations we can't really do this, right? So what we can do, we can hash the strings, and store it into the map. That could be one possible solution. So I have used string hashing here. Like Rabin curve string hashing you can use to store it into the Rabin curve, uh, into the map, right? That's what I have done here. So our so what we will do, we will do dpij equals to the minimum what we can say, minimum cost to convert I to j, I string to j string. So here for finding I and j we are using integer indexes for this dp array. So we are doing some kind of mapping, like let's say we have some string original and changed, right? So we can put all these strings in a set, and we can map every element in the set to a integer. Okay, so let me show you my code, then that would be better. So here what I am doing, I am putting every integer from original and changed into a set, and I am in a map in the indexes, you can say. We are putting the hash of the string as with the map of c. We are mapping every string to a integer value c. That's what we are doing here. And after that we are calculating that this is the, what we can say, this is the Poirot algorithm to calculate the distance between I and j. You can find this algorithm, distance of ij equals to distance of ik plus kj. This is order of n cube, right? M cube. So that is done. We have dpij now, or you can say this is as distance of ij. After that what we will do, let me clear these things. So we have already built our map, distance of ij, with indexes I and j. Now what we will do, we will do some kind of recursion here. Okay, so we will do some kind of recursion on the index of our uh, source string, right? So let's say we are taking some strings from s of I, or let's say source. So let me write as source of I to j. If source of I to j could be changed to target of I to j, then we will do this operation will give us some cost. Let's say the index of source of I to j, let's say, is p, and index of target I to j is q. Then the transition will be cost of uh, distance of p distance of pq distance of pq plus recursion of, you can say, j plus 1. Okay, so that's what we are doing here. We are doing this transition. If source of I to j could be converted to target of I to j, then our transition will be distance of p comma q, where p is the index of source of I to j in the s set, and similarly for target I to j will be q, the index. Now distance of pq plus we are converting the string s of source of I to j to target of I to j. So this is done. Now we are jumping into the next part, recursion of j plus 1. I hope you got it. Now what is the optimization? The time complexity could be like, for every we are doing recursion of I, and for every I we are iterating over j's, right? For every I we are iterating over j, so the time complexity will be order of n square. Now the time complexity is so strict that this order of n square solution is not allowed, so we have to think about something more, right? So what more we can think of? So the further optimizations I have seen in people's code is that instead of iterating over every j, we can only iterate over the length of the substring, like source of I to j. Let's say the length of this will be j minus I plus 1. So we, instead of iterating over every j, we can iterate over the length. Why? Because the m value we have is 100, and so there could be only 100 possible lengths. There could be 100 possible lengths, so we can iterate over these lengths, and we can solve the problem in order of n m into some constant time, right? So let me show you my code now here. this part I have already explained how we are mapping any string to a index, right? And Here's I am inserting the size of a string into the array, right? We are inserting size of the string into the array. Now here this is the initialization part of the Floyd-Warshall algorithm. If there is a age between I and j, then we are doing distance of ij equals to cost I. I hope you get it. Now this part is the Floyd-Warshall algorithm. Now here we are doing the recursion with starting index 0. Now if here is the recursion, if I is the last index of the string, then we are returning 0. Now this part is memorization, right? So here instead of iterating over every indexes, every j, we are iterating over sizes, right? Now if I plus j is greater than n, then it is not possible, right? Because we can't take the any string. J is all sizes is already sorted because I have taken sizes in a set. So if I plus j is greater than n, we can't do further processing for any sizes which is greater than j. So we are taking the hash of string substring of I comma j, and similarly taking hash of substring from I comma j, right? Now if the hash is present in the our index array, and similarly hash of b substring is present in our index array, we and the distance between them is not equals to infinity, so there is a possible way to change the substring of a to substring of b. We are doing answer equals to answer of minimum of here distance of p comma q plus recursion of I plus j. Here we have taken the index, sorry, we have taken the size, so I plus j will give us this j plus 1. Okay, I hope you got it. Now this part, this optimization part, I am not really sure because we are also doing a substring operation, so that overall time complexity is not really order of n into m, it is something really order of n m square. So how this solution passed, I am not really sure, because if this solution passes, then order of n square solution what I have done using hashes should also pass. I'm not really sure why this solution passes and that solution not. But I hope you got my solution. What I am trying to say. Like the entire approach is kind of same in both the approaches, but the one optimization, or you can say what one difference, is the iterating over lengths instead of iterating over the end indexes. That change the verdict from time limit exceeded to AC, right? So I will provide the link of the code in the description box. If you have any doubt in any part of the video, you can always write in the comment section. I am not explaining the third problem itself because the main idea is same, like doing some kind of what you can say Freud version to get the minimum distance to change any character to another character. In the third problem, the original and changed array only consists of characters instead of strings. So the problem is the third problem is a subset of this problem, so that is also solvable using this approach itself, so I am not explaining that problem. So if you have any doubt in any part of the video, always write in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.